In this lesson, we're going to examine something we've seen before, proportions, things that are equal but different. We're going to approach them from a more algebraic point of view this time, as opposed to just a numerical one. So some quick reminders. A ratio is a way of comparing things that don't have the same units. And we usually have a colon between them. So for instance, if we have 12 students and they're choosing lunch, and 5 chose pizza, 7 chose hamburgers, the ratio of pizza to hamburgers, and we've seen this question before, would be 5 to 7. When we change that into a fraction, 5 to 7, we often made equal but different ratios. We call them equivalent ratios. So for instance, if I times this whole thing by 2, 10 and 14 would be something that's equivalent, equal, but different. Okay, you could also make them smaller or bigger. So we talked about multiplying and dividing. And that way we're totally fine. There's nothing wrong with that. But there's an algebraic expression we could do to do the same thing, which we'll look at in just a second. So give me something equal but different, in other words equivalent to 3 to 4. And we talked about, most of us do the lazy one, 6 to 8, just double it. Or the other lazy one, 30 to 40, times it all by 10. But again, as I said, we don't always have to make them bigger. We can also make them smaller. So if I had 24 over 18, I could divide it by 6, and I'd get 4 to 3. Okay? Or divide it by 2, and I would have got 12 to 9. Okay? These are all things that are equal but different. In fact, if you notice, I put an equal sign between them, right? They're equal but different. This is kind of one of our key ideas, that if I was missing one of these 4 numbers, I could find it by figuring out the factor. Well, as I said, we're going to try that in a slightly different way. So the fact that things are equal but different, we call that a proportion, is a really powerful idea. If you notice, 12 times 2 makes 24, and so does 8 times 3. And that's always true, no matter what, if you have a proportion, 2 fractions that are equal but different. We call this the cross product rule. What that does, it allows us to solve a problem without actually having to figure out the factor between them. So today we're not going to try and do the times by 2 or divide by 3. We're going to try in a slightly different way. So if you use this big idea where we can cross multiply, that's what we're going to call it, cross product or just cross multiply, we can actually figure out the unknown value without figuring out the ratio between them. So let's start with a simple one that we've seen before, and we figure out the factor. But let's try it in a different way. How's this going to work? Well, I'm going to multiply diagonally. 48 times x makes 48x. And 4 times 36 is 144. And I know these two things have to be equal because I have a proportion, 2 fractions, that are equal. Well, that gets rid of the fractions for me. How do I solve this? Our big idea from yesterday is, if I have things that are multiplying, which I do, I can get rid of them by doing the opposite. Divide by 48. If I do one side, I do the other side, and x is 3. We've solved it. That's it, that's all. Okay, we'll try the next one. 32 times y makes 32y. Notice this time, I did the diagonal from right to left first. I want to get my letters on the left-hand side if I can. This makes my life a little bit easier. 8 times 45 is 360. So my fractions are gone. I need to get y by itself, so I'm going to divide 32 by 32. If I divide one side, I have to divide the other. Those two cancel each other out, and I end up with 11.25. Decimals are fine. Keep 2 of them if we have to. This actually turns out to be a nice decimal, and that's okay. All right, let's try some more things. 5 to 30 is the same as 45 to x. Well, we don't really like ratios with colons. Let's turn them into fractions. So 5 over 30 and 45 over x. Okay, let's cross multiply. 5 times x makes 5x equals 30 times 45 makes 1,350. That's what 5x's is. We don't want 5x's, we want just x. Whatever I do to one side, do to the other. So x comes out to 270. We're trying to eliminate the idea of having to find a factor, and we're doing it with a more algebraic method. Okay, you guys give the next one a try. Pause it, see if you get it right. A over 16 is 5 over 20. Okay, 20 times A is 20A. 5 times 16, 80. I don't want 20 A's, I want to get 1A. So I divide. If I do to one side, do to the other, and A is 4. We'll try the last one here. 3 over x, 50 over 80. Let's do the letters first. And then the numbers. We want to get just x, so we divide by 50. And 243 divided by 50 comes out to, ooh, that's a weird one, 4.86. And that's okay. Decimals are fine. Just keep 2 of them. Okay, there's our skill. Here's how we apply it. It's similar kind of questions we've seen before. Ratio problems, we're just going to solve them using algebra. So, the sail on a sailboat has a height to length ratio of 3 to 2. Let's write that down, 3 to 2, and it says height to length, so this is my height, this is my length. That was one of our tricks way back when, put some letters in there to remind us what we're doing. The height of a sail is 9. Okay, height is on the top. How long would the sail be? That's my x, the thing I don't know. That's exactly the same things we just did. Cross multiply, so 3 times x makes 3x. 2 times 9 makes 18. I want to get x by itself, so we have to divide by 3, and x is 6. Therefore, the sail is 6 meters long. And word problem, word answer. Try another one. At a local event, the ratio of hamburgers to hot dogs is 5 to 3. 5 to 3. Hamburgers came first. Hot dogs came second. The number of hamburgers sold is 275. Okay, it says hamburgers, and hamburgers are on the top. How many more, keep that in mind for later, hamburgers and hot dogs are sold? There's my x. Okay, cross multiply. 5 times x. 3 times 275 makes 825. That's 5 x's. I want to get 1 x. So divide by 5, and we get 165 hot dogs. And what was the question? How many more, remember, so keep that in mind for later, hamburgers than hot dogs? Well, hamburgers was 275, hot dogs is 165. The difference between them is 110. So 110 more hamburgers were sold. Okay. Last one. Janice and Irene buy apples at different stores. Janice pays $6 for 375. 3.75 kilograms. Irene pays $5.25 for 3 kilograms. How much more will Irene pay than Janice? Okay, we've seen a question like this before. We did it with unit rates last time. Let's try it with algebra this time. $6 for 375 kilograms. We want to know how much 9 kilograms costs. There's my x. Let's solve it. 3.75 times x is 3.75x. 6 times 9 is 54. I want to get x by itself, so I've got to divide by 3.75. Okay, so for, who is this? Janice. This is Janice. X comes out to $14.40. How about Irene? Irene paid $5.25 for 3 kilograms. Now she's buying 9 kilograms. And if we cross multiply this one, 47.25, oops, that's our order. 3 times x is 47.25. X by itself. And I get $15.75. Now, again, this is just a method using algebra. We could do other things. For instance, maybe you recognize that, oh, I'm just tripling it, right? Times it by 3. We can go back to that old method. It works totally fine, and in some cases, it actually works faster. I'm just trying some algebra today. Okay, what was the question? How much more does Irene pay? Well, Irene definitely pays more, and this is higher than this one, but by how much? Well, let's figure it out. 15.75 minus 14.40 comes out to $1.35. Therefore, Irene pays $1.35 more than Janice. Okay. And those are proportions. Set up fractions that are equal, and we can always cross multiply diagonally. Okay. Get the letter by itself by dividing out, and you've got your answer. Again, you can go back to the old method if you want to, and it totally works, but we're just trying to use an algebraic method today, so try to give me the algebraic method if you could. Okay. Try this on the website. If you're stuck, come see me.